Alright, students, I hope you're ready for another fun video lesson today. Well, today, students, we'll be looking at section 2.6, fractions and decimals. If you've been paying attention to anything we've been doing so far, you know we have been dealing with fractions. Well, now we're going to take a look at fractions and decimals because they are very similar. They both allow us to represent numbers between whole numbers. Or another way to look at it is numbers that might be less than 1 but greater than 0. Alright, so let's begin. Remember, if you need more help, you can always look at examples starting on page 96. First, you need to copy down this definition. Terminating decimals, a decimal that stops. Remember, you can always pause the video, but I'll keep moving on. Example 1. We are told to write as a decimal, and we are given these two fractions. Let's look at A first. A gives us the fraction 1/4. We're told to write this as a decimal. Some of you might remember how to do this. If you have forgotten, please pay very close attention. Even if you remember or think you remember, please pay close attention. You might have forgotten something. All right, so we have 1/4. We write this in long division terms to help us get the decimal. So we say 4 into 1. 4 goes into 1 how many times? Well, it can't. So what we do is, remember, we put a decimal here, we put a 0 here. I recommend that you go ahead and put your decimal up here. It helps you to not forget to do it. Very often students forget to put it there. Put the decimal there. So you have 2 decimals, see? 4 goes into 10 2 times. Remember to multiply back. You would get 8. You would end up subtracting to get what? 2. You would bring down another 0. 4 goes into that 5 times. And if you multiply 5 times 4, you get 20. And that's going to get us to the end, okay? So this as a decimal is equal to 0.25. All right? You want to make sure you have enough room. Okay, you might want to space a little bit more than I have. Next, we have 3 into 8, or 3 over 8, I mean. We put the 8 on the outside, and 3 goes under the hood, as some of you like to say. 8 cannot go into 3, but if we put our decimal here and here, put our 0 there, 8 goes into 30. It goes in there 3 times. Multiply back, you get 24. Subtract, you get 6. Bring down the 0, because you have to make a second 0. 8 goes into 60 7 times. 7 times 8 is 56. Subtract, you end up with 4. Bring down another 0. 8 goes into 45 times, and it's going to go in perfectly because 5 times 8 is 40. So we're done. So our decimal this time is, I'm going to write it over here just so we see it clearly, 0.375. I cannot talk today. 0.375. There we go. Voila. And that's your answer. So, if you want to write over to the side, to write a fraction as a decimal, just use long division. Or you could just say, just divide it. All right, we have another definition. You may want to skip a line. Mine's getting a little close. You might want to skip a line to give yourself a little bit more room. A repeating decimal is a decimal that has a block of digits that repeats without end. And you're thinking, a block of digits? What? I'll show you what I mean by that. For instance, in this first example here, we have 0.22222. You see, the 2 is repeating throughout the entire thing. This is known as an ellipse. It just lets us know that this continues forever. To write this out would be really tiring, so what they did was they found a way that you can write a repeating decimal in a much simpler way. You can put 0.2 and put a line over it, and that lets me know that the 2 repeats forever. Okay? Another example here, we have 5.4777. So the 7 is repeating. And you don't put the line over everything. You only put it over the number or numbers that repeat, so that you put it only over the 7. Now, just so you know, you can have more than just one number that repeats. For instance, here we have 0.353535, and it keeps going on forever. So you put the line on this time over the 35 because it is the block of digits, you would say. It's the block of digits that is repeating throughout the decimal. So that's a repeating decimal. Now, write as a decimal. These are some fractions that are equal to repeating decimals. So if we set this up using long division, where we have 3 going into 2, I would have to bring down my 0, or put a 0 there, put my decimal there and there. 3 goes into 26 times, you would get 18, you would get 2, you would bring down another 0, you would get 6, you would get again 18, you would again get 2. Once you start, you can't do this right away. You can't just go and say, hey, it seems to be repeating because I keep getting 6. That's a key to look at, but the real key is to notice, do you have a pattern down here for me? I've got 20 and then 18 and then 20, then 18. I'm going to get a 20 again and you're going to get an 18. If you see a pattern down here, that tells you that this is going to definitely keep repeating. So instead, we just simply write this as 0.6 repeating. If you don't put the line over the 6, it will be a wrong answer, so please make sure you're paying attention. Now over here, we're going to put 11 into, make sure I can box this in real quick, sorry. 11 into 5, can't do it. Put my decimal, put my 0. 11 into that would be 4. You would end up with 44. You would subtract, you would get a 6. You would make it a 60. Make it a 60, because you bring down another 0. 11 into 60 is 5. Multiply back, you get 55. You're going to subtract and get 5. You're going to get a 50. Multiply that, you're going to get a 4. Multiply back, you're going to get a 44. And hey, we've done all this before. You recognize what's going on there? You're going to get a 5. And you see a pattern that's repeating. Okay? You got to look here. Because there are times when you can get 2 numbers in a row up top, but you can get them different ways down here, okay? So the key is, if this kind of makes you think you're going to have repeating, look down here and see if you're doing the same thing. I have 50 minus 44. I get 60 minus 55. I have 50 minus 44. Hey, I just did that up there. That's going to get me a 6 again. Make that a 60. Oh, you see a pattern. So this is equal to 0.45 repeating, okay? Remember, key is to look not just up here, but down here. All right, now we're told to write as a fraction. Yeah. This is actually pretty easy. I think it's easier than the long division, personally. Okay? And what we're going to focus on with this is just looking at terminating decimals and terminating decimals with mixed numbers kind of thing. We're not going to worry about repeating decimals this time around. There is a method you can use, but it is very complicated, and we're going to wait more for pre-algebra to get into that. So here's what you do with terminating decimals. You say I have one number past the decimal. So I take 7 and I put it over 10. Here I have two numbers past the decimal. So I take 75 and put it over 100. The reason why you do this is because 0.7 is actually read as 7/10, because that's in the tenths place. Look, 7/10. This goes all the way to the hundredths place. So you read this as 75 hundredths. 75 hundredths. That's why you do that. An easy way to remember this is if I have two numbers past the decimal, you put it over 100 because 100 has two zeros. You put this over 10 because it has one zero. That might be an easy way to remember it. And the last one, we have a 2-point this. You don't put the whole number over the fraction. You leave that out front. So you put the 2 right there, and you put the 125 over 1,000 because you have three numbers past the decimal. Okay? We're not done because you will be told to write these in simplest form. So let's go back and look if they're in simplest form. This one is in simplest form. This one can be reduced by 25 to get 1/4. This one over here would reduce to 2, and you would end up with, because it can reduce by 125 on the top and 125 on the bottom, you could reduce this down to 1/8. Okay? I hope that makes sense. Remember, if you have any questions, ask. We are going to look at something else in just a minute. Let me see. I think we have one more thing. Yes, we do have one more thing to cover. One last thing to cover. You may be told to order from least to greatest. Okay? And you might be given, we've done this before. We've done this with integers. We've done this with fractions. I believe we've even done this with decimals. Now they've given us a mix of whole numbers and decimals and fractions. So it's very important to look carefully at it. On this time, I'm told to order from greatest to least. Well, just take a look up here, or right here, and see what you think is the biggest number. I've got 2, 2.4, 2 and 6/18, and 3. To me, obviously 3 is the greatest and 2 is the least. The question is, which one of these is bigger? The easiest thing that I know personally to do is to convert your fractions to decimals. That's going to be the guaranteed way to get to your answer, okay? So what I do is over here to the side, I'm going to say I've got, 2 and 16/8. I just want to know what this is as a decimal. So I'm going to say 18 into 6, okay? So I'm going to have to make that a 60. Put my decimal there, put my decimal there. 18 into 60. How many times will that go into that? Well, I'm thinking, let's try 3 times. 3 times 8 is 24. 3 times 10 is, so we get 50. So with that, we get 54. And you're going to get a 6. You bring down the 0. You multiply back. Hey, we've already done this. You get a 3. Multiply back. You get after you subtract, you're going to get that. Bring it down. You notice a pattern forming here and up here? Yeah, this is going to equal 0.3 repeating. So this number right here is equal to 2.3 repeating. So which is bigger, 2.4 or 2.3 repeating? 2.4. So 2.4 comes next. and then the 2.3 repeating. But we can't write it as that. We have to write it as the original, so we would need to write it with the 2 and 6 over 18. We will go over more examples like this in class, so please write down any questions you might have. Go back over it and look and see if you understand it all. If you don't, put a question mark by it and be prepared to ask about it in class. You know, be like, Mr. Preston, could you work another example like example 4? I'll be more than happy to do so.